Okay. I guess I'm moving. I don't want to move that over. Okay, so I got negative 3x equals negative 27 divided by negative 3 from both sides. I get x equals what, Rodelia? Sorry, I did that fast.
Sorry. What?
No, you're good. What is negative 27 by divided by negative 3? What's it's not 8. What is 27 divided by 3? Okay.
Yeah, I don't know.
It's 9.
Oh, it's 9.
Yep. I'll teach you multiples of 9. There's a really cool trick that I love. Okay. X equals 9. Do we have any questions? No, because you got it? Or no, because you're confused? Okay. We still need to find the measurement of UV. This measure right there. How do I find that right now, Klein?
Measure UV?
Yep.
The arc or?
Yes, the arc right there. The small one. With the hands, no. I like mine way better. So this is the arc measurement. It tells us, but it gives it an expression. So I found that x equals 9. So I'm just going to plug in 9 for it, and I'll get my value. 5 minus 27 equals what? 18. So I got the measurement to be 18. Mm-hmm.
Of the arc or the line?
Of the arc. So if this arc is 18, what is ST? 18. Same arcs are going to be congruent. Same chords are going to be congruent. Yeah? On a scale of 1 to 3, how challenging was that before I showed you how to actually do it? Before showing you how to do it. 1 easy, 3 hard. Okay, is it just remembering the theorems? Okay, we'll do a whole big giant worksheet of it. No, when we finish, because we only got, what, 2 left?
Oh, I thought we finished yesterday.
No. We did a new theorem yesterday. Okay, I hand you all back the note cards. Do we need to go over that problem?
Yeah.
Yes.
Wait, how do you know when's to divide and when's to together?
So, I wish I had the thing up before. If I want an angle, I want to do half of the arc. Okay? Half of the arc. That's intercepting. If I'm finding the arc, then I'm going to be multiplying the angle. Okay? So divide arcs, multiply angles. Okay? If we're talking about angle, and I want to get the arc, I have to multiply by 2. Do you want to put that in an image? Okay. Well, I'm talking about inscribed angles. This is not what we did yesterday in our note card. That's not that note card. A note card had 2, let's just divide that. Don't write that. Yesterday we started with a circle and what 2 types of lines? Yeah, we had a secant and we had a segment, which we can just say is 2 different secant lines. So we had it here. Angle 1. And we have the intercepting arches, so A and B. What did my theorem say about angle 1 equaling?
1/2.
Yep, so angle A plus the other arc that's intercepting, so B. We are intercepting those 2 arcs. That's where angle is facing. So whatever arc is opposite my angle. There. That's review of yesterday's theorem. Yeah. What? How? Okay. Okay, what was my numbers?
For A, it's 74, and then for 1 inch is 107.
74, and this one right here was 107. Yeah, Klein. Yeah, go ahead. Okay. We know the angle already, right? Angle 1, it could be angle 2, it does not matter. Because angle 2 also equals 1/2 A plus B. Because it's still the same two intercepting arches. So, I know the angle, right? I know my angle. I know one of my arches right there. I'm trying to find what B is. So B over here. Okay. All I have to do is get B all by itself. There's two ways to do this. What is your first instinct? Okay, let's do distribute. Distribute, distribute. So 107 equals half of 74, which is 37 plus half of B. Okay, combine like terms. Sophia, what should I be doing now? Yeah, minus 37 minus 37. So I should have 70 equals 1/2 of B. You can scooch up on the other side of Tristan if it helps you. Okay. So how do I get rid of the 1/2 and get B all by itself? Times 2. Times 2 on both sides. So that's 140 equals B. And that's what we're trying to find. So 140. Okay. I gave you notes on the note card, but we're going to move on from that. We're going to move on to our next theorem. Theorem. I feel like it's not 10.8 because I'm looking at the wrong. Yeah. You're at. What's the question, Sonny?
I'm just confused on the.
Times 2?
No, there's the same equation, but one is like angle 1 equals and then angle 2 equals.
So, because these two are vertical angles, right? So angle 1 is congruent to angle 2. Yeah. So vertical angles. So it doesn't matter. If I start here at this angle, what are the two intercepting arcs? If I'm going here, what, it's opposite of B, right? Okay. What is the arc opposite of that? A. Yeah. It's these two arcs. So think about like it's the angle. What arc is inside that angle? We're talking about this angle right here. The arc inside of this is B. And of this one inside of here is A. So we're going to take the sum of those two. And then divide it by 2. Yeah. Okay. Okay, next theorem. Well, next and almost last. 10.11. Okay, I am going to give you the wordy version of this. If you don't want the wordy version, just don't write it. But it's the measurement of an angle formed by two lines of an angle formed by two lines. Now, before those two secant lines, Gian, where do they intercept? The two secant lines in our past problem, they intersected where? Inside the circle. These are going to intercept outside the circle. New thing. So these are outside circle. That intercept outside the circle. Underline that part of the theorem. We're now going outside of the circle. It's still going to be half, but it's not the sum anymore. It's going to be the difference of the measurements of the intersecting arches. Of the intersected arches. Arcs. Whew. It's been a long day. Yeah. Well, there's gonna be two. There's gonna be multiple. So arches. We'll say multiple. Okay, think about this in your head. Close your eyes. Think about it in your head. You have a circle. You have two lines that are gonna touch the circle somewhere, and they intersect outside, making an angle outside of this circle. You have a circle. Okay, you got two lines. They're gonna go through the circle somehow, and they're gonna meet outside. I want you to draw whatever image you see right now. Put it on your paper. Draw it. Draw what you're imagining. You have a circle. You have two lines that are going to go through the circle or touch the circle somehow. And then they're going to meet outside the circle, forming an angle. Draw whatever you think. Okay, that's case 3. That's case 1. That's also case 1. You gotta meet outside. Okay, it has to meet outside, right? Outside? Okay, really small case 1. You got case 3. You got case 1. You got case 1.
Wait, what case are we trying to get?
Oh, that's case 1. We have like 3 different cases.
Miss Sweet? Miss Sweet?
Relax, dude.
Miss Sweet?
That's case 2.
Yo, relax, dude.
What case is this?
Those aren't lines.
Yo, relax. I have that day.
Okay, we all got at least all the cases. We just drew them a little differently. Vincent,
You go in the corner for like 5 minutes.
I didn't hear it. I'm sorry. Case 1, drawing a line. Case 2, don't fight inside the school.
Did you watch a fight outside this?
I have been in the middle of fights and how to stop kids from hitting each other. Like, oh no, I would never hit a kid. Never ever would we lay hands on a child. Never. With context. Okay. Draw a circle. Okay, case 1. We're drawing it right now. You guys drew 2 lines that hit 2 points in a circle and met outside. Those green lines are what type of lines? Yep, 2 secant lines. Okay, and there's an X right there. It formed this angle X. So angle X. Okay, next one. Vincent, you're the only one that drew the second case. No, you drew case 3, I think. Okay, we're going to take a secant line. And then, Vincent, what other type of line did you draw? Yep, and you drew 1 tangent line. Like so. And that met right there. And it made an angle right there. So, 1 tangent line plus 1, what do you mean small? Oh, plus 1 secant line. That's case 2.
Is case 3 just 2 tangent?
Yep. A lot of you guys also drew this image. Ooh. So we got 2 tangent lines. Riley, how do I draw a tangent line? Like that?
Yeah.
I think that's a secant line. I think I have to do something.
Stop inside.
I gotta touch.
Oh, yeah, like that.
Yeah, I gotta touch exactly 1 point on my entire circle. Okay, then I got a second one right there. So I'm touching 1 point right there. I made angle right there. So this is 2 tangent lines. And I made angle X. Okay, Rogue. Case 1. How many arcs did I make in a full circle? Yes. Yeah, you made 4. So let's call this 1, 2, 3, and 4. Which ones are they intersecting? Which ones are inside the angle? So inside of these 2 lines, 1 and 3. So we are doing is 1/2 the, yes, but we're gonna do, our equation said we want the difference of them. So difference is subtracting. So difference of, we're not call them 1 and 3. We're gonna call them A and B. A, call this A, and this B. I want my larger one to always go first, okay? Larger one always first. So B minus A. So we'll just put this like this. We always have larger arc minus smaller arc. So again, case 3, how many arcs do I have? Yeah, you got 3. So you got 1. Well, on case 2, how many arcs do we have? We have 3. Okay. Which 2 are they intersecting? 1 and 3. Yep, they're both inside the angle. So I'm finding the difference of the same formula. We're going to have the same formula for all 3. So 1 has become A. This one's A, and this one is B. So the difference of the larger one, Klein, minus the smaller one. It's the same thing for all 3. It's just 3 different cases of the same theorem. A is down here. Yep. No. I think I just made it worse. Now, Klein, how many arcs? How many arch? I keep saying arches. How many arcs do I have in number 3?
2.
2, right? Okay, if I add those 2 together, what do they add up to in degrees?
360.
Yep. I want to make that a note for a second. Let's draw that. Add up all of the arcs in a circle. We get 360 degrees. Okay. This is where A is, and this is B. Elijah, which one is the major arc in this case? B? Yep. So we're doing 1/2 of the major minus the minor. Boom. Cool. Fun, right? Yeah?
16 I'll draw my circles.
You're never going to be done with circles. It's the cornerstone of this. I know. It's okay. I also have to do them in pre-calc too, so. Yeah, and calc. Okay. I'm going to scooch it down a little bit. Okay. Do we want to test them out on our own? Or do we need a practice? No board, because we took away the privilege of boards. So we're doing individual. Why? Because the quiz was not pretty. Well, okay, people that are not here. These are the problems that we just went over in class. As in, you all did these independently. Pause to get them and work on them. That guy right there.